Assalamualaikum and hello to all. We are going to proceed to chapter 2.5, Chemical Properties of Alkanes. At the end of the lesson, you should be able to explain the reactivity of alkane, describe the combustion of alkane in excess oxygen and also in limited oxygen, explain the mono substitution of alkanes containing equivalent type of hydrogen atom, explain the free radical substitution mechanism, or C, this one. Yeah. Okay, chemical properties. What is chemical properties? Chemical properties is actually chemical reaction of alkanes. So alkanes is generally unreactive, but it can have chemical reaction, that is combustion. For combustion, there are two types, one in excess oxygen and one is in limited oxygen. So in excess oxygen, what you have is alkane and excess oxygen, and the product that you are going to have is carbon dioxide and H2O, and also large amount of heat is released. For example, shown to you here is methane. This is methane undergo reaction with 2O2, so it produces CO2 and H2O. So the product is CO2 and H2O, and the energy here given for you, if you have 1 mole, it actually can give out 890 kilojoule of energy. This energy is heat. So that is methane. In limited oxygen means that your oxygen is limited. Okay, your oxygen is limited. So not all of the carbon is going to be converted into CO2 because oxygen is limited. So it forms a dangerous gas, which is carbon monoxide. If you have heard about this, carbon monoxide is the gas that comes out from exhaust gas, and if you have a leakage that can get into your car cabin, it can poison you. Okay, so this one is for excess. This one is for excess. Methane react with excess oxygen, you get CO2 and 2H2O. Okay, this one is excess. But what about in limited oxygen? Means that this one, this part oxygen is limited, so it is not 2O2. So 3/2 O2. So this one is limited. So what is being produced is CO, the poisonous gas, the carbon monoxide. And you can also have one more in very limited oxygen. So in very limited oxygen, let's say you have 1 mole of oxygen only. So it will produce carbon. Okay, carbon, not even carbon monoxide, not even carbon dioxide. So carbon in the hydrocarbon that is burned here is actually soot. Soot is the dark smoke that you see. Okay, so that is actually carbon soot, or in Malay we call that jelaga. Okay, next chemical properties that can occur to alkanes other than combustion in excess oxygen and in limited oxygen is halogenation. So halogenation means that you are going to have halogen in your alkanes, and the type of reaction that follows this one is free radical substitution. So alkanes, this one should be alkanes. Alkanes react with halogen such as chlorine and bromine to produce haloalkane in presence of light. Light is UV, or temperature greater than 100 degrees Celsius. So let's see this one. So this is alkane. Okay, this is alkanes react with halogen. This is halogen. Okay, this is light. Okay, sunlight. Sometimes it is written down H nu. This is not V. This is nu. H nu or UV, or sometimes also just written down as sunlight. So what happened to these alkanes is free radical substitution, where it becomes haloalkane. So haloalkane, it forms to become haloalkane, and the byproduct here is HX. If X here, for example, is Cl, so it will replace one Cl will replace H here, so this one will be RCl, and this one also will be HCl. So HCl is the byproduct. So with methane, reaction produce mixture of halomethane and hydrogen halide, but you only need to know about mono substitution. Okay, mono substitution means one hydrogen only be replaced with halogen. So for example, CH4 react with Cl2. Okay, this is earlier is the RH. Okay, this is earlier is X2 with the presence of UV. So you will get mono substituted alkane, which is CH3Cl. Okay, Rx. This is the haloalkane, and this one is the HX. Okay, so this is the product. This is product, yeah. This is product, and this is byproduct. Okay, so this is the reaction. This is methane. What if you have ethane? Okay, this is ethane. Okay, so ethane, the same thing. What you need to look for when there is UV, one of the H here will be replaced with chlorine. Okay, you should be able to see the pattern here. This is Cl2. Okay, Cl2, one Cl is attached to this part and one Cl is attached to this part. So it means that one Cl from Cl2 here will be attached. Oh, sorry. CH2Cl, and one more will be with this one. Okay, 1 Cl, 2 Cl, and this is also 2 Cl. Okay, so if I write down again, this is the RH, this is the X2, this is the Rx, and this is the HX. Okay, let's see the actual equation. Okay, with the presence of UV. Okay, the same, huh? So you get Rx and HX. Okay, next one. Okay, is this balance? This one supposedly. Okay, this one supposedly have one more CH3. Oops. Sorry. CH3 and one more CH3 here. Okay, it is not being drawn. Okay, so one H will be replaced. So one H from here will be replaced with one Cl2 from here. So you will be able to see Rx. So this is Rx. So Cl is being replaced by one oxygen, one hydrogen, and also one here. Okay, so this is free radical substitution. Okay, number 4. Okay, number 4 here is about selectivity. Selectivity for Cl2. It is not selective. It is not selective. So what you will get is major and minor product. Okay, major and minor product. Okay, for major product, it will follow the one which have higher stability. Okay, the one that have higher stability depends on the class of carbon. Okay, this one is primary, this is secondary, and this is also primary. So this is the class of carbon, and you can replace from Cl2 here, you can replace hydrogen from here, hydrogen from the secondary, or hydrogen from primary. But the one which is more stable is towards tertiary. Okay, free radical is the most stable when it goes toward tertiary. So the one which is more stable will form the major product. So you can see that the Cl will choose to replace the hydrogen from secondary. So this is from secondary, and this one is from primary. Even if you replace the hydrogen from this side, it will be the same, because still primary, right? So the one which is higher stability, which goes toward tertiary, will become major. So this is major, where it gets 55% and 45%. So Cl2 is not selective. It is not selective. Whereby if you have the same thing, propane, react with Br2, you only get one product. Okay, one product here, because Br2 is selective. Slow and selective. Selective means it will always try to form the most stable haloalkane. And the most stable haloalkane, as I told you earlier, it is about towards tertiary. So it will replace the H that is attached to the secondary carbon. So this is the product that you get. 2 bromopropane only. Okay, almost 99%. Okay, 1 more percent is maybe the byproduct. Okay, chemical properties of alkane. Still free radical substitution. So we are now looking at reaction mechanism. So reaction mechanism is the movement of electron. Generally, it is about movement of electron. So let's consider this reaction: CH4 plus Cl2 forming UV. and becoming CH3Cl and HCl. So we want to look how the electron move. So there are 3 steps. So the steps are initiation, propagation, and termination. This one you can remember with the short form IPT. Okay, and this is most important. IPT, and actually for initiation step there is 1 step. Propagation, there are 2 equations. Okay, initiation is 1 equation, propagation is 2 equations, and termination is 3 equations. So you can short form this by using IPT 1, 2, 3. Okay, IPT 1, 2, 3. You will see what 1, 2, 3 refers to. Okay, so for step 1, initiation. Okay, initiation is 1. Initiation is 1. 1 is referring to 1 reaction only. Okay, so light or heat provide the energy needed for the homolytic cleavage. So free radicals can be formed and reaction can begin. Okay, so we can see this is actually Cl2. This is actually Cl2, but we draw like this because we want to show the movement of electron. So the electron will move like this. Okay, it will move from, this is actually a bond. So electron will move towards 1 chlorine and also 1 more to 1 chlorine. The arrow that I draw here is single-headed arrow. The arrow drawn here is single-headed arrow to show that only 1 electron that move. Okay, so let's see a proper one. Okay, single-headed arrow. So remember, you need to have UV for the reaction to occur, as it is the energy needed. Okay, so step 2, propagation. Okay, propagation, this is from the product on the reaction earlier. So Cl here will break the bond from C and H here. So this one, okay, draw like this and maybe like this. Okay, single-headed arrow, and this bond will break to go to the carbon. Okay, so let's see how will it works. Okay, so it breaks. So what you get is HCl plus, now you have methyl radical. All this part now become methyl radical. So that's why it's called propagation. Propagation means it propagates to another compound to become free radical. Okay, so this one now become free radical, which is this one, methyl radical. And remember, propagation is 2, so means there are 2 reactions. So one more reaction is this one. So we take the product from the previous reaction, which is this one, and this one will react with another Cl2 which is available. So you can see what happened is you will get CH3 Cl plus 1 more propagated compound that now become free radical. So this is free radical. This is called free radical. Free radical. Free radical. Sorry. Okay, so let's see. Okay, single-headed arrow. So methyl chloride and also chlorine radical. So chlorine radical is free radical. This is the free radical that we are looking for. So as you can see, UV is no longer written here, right? Okay, UV is only needed for the step 1. For the second step, no more UV needed. Okay, so step 3, termination. Termination means the free radical terminates. So this one, CH3 methyl radical will react with chlorine radical. So this one will be terminated. It will become CH3Cl. And this one will also be terminated. It will become CH3 and chlorine radical also react together. So this one will become Cl2. Okay, so how many reactions are here? 3. Okay, so there are 3. So that's why I say for you to remember the mechanism here for free radical substitution, IPT 1, 2, 3. So remember, initiation 1 reaction, propagation 2 reaction, termination 3 reaction that you need to draw. Okay, so you need to do exercise for this topic. you to be able to remember all the steps that is involved. Okay, this is the proper one. Okay, the same thing with what I draw. Okay, so you also get Cl. You can also draw like this, or like what I draw earlier, Cl2. The same thing. Okay, this one we want to look at the stability. The strongest CH bond is from methyl. Okay, methyl, whereby the weakest CH bond is from the carbon that is tertiary. Okay, this is tertiary carbon, because R, if you still remember, R here is EDG, electron donating group. Electron donating group. So increasing CH bond strength, and this one is increasing ease of H abstraction, means that easier to remove the hydrogen. So based on this, which one you think, okay, tertiary, secondary, primary, or methyl, which one is easier for the free radical to react with? Okay, of course it refers to tertiary, because tertiary is the easiest to remove the H, right? This one you want to replace with Cl or the X, so easier to remove. So the weaker the CH bond, the H is more readily to be replaced in radical halogenation. So tertiary is the most stable and the more favorable product to be produced. Okay, so non-reactivity of alkane. This is related to the chlorine and bromine earlier. In general, bromine is less reactive towards alkanes than chlorine, but bromine is more selective in the site of attack when it reacts. So, the percentage of product yield based on stability of free radical, tertiary free radical will be favored compared to secondary and primary, okay, due to stability. Okay, so that's it for today. So I hope you can study about this, and good luck.